Hello students, let's talk some more about simplified radicals. An expression with the radicand is simplified when all of the following conditions are satisfied. Number one, the radicand, that's the thing underneath the radical, has no factor raised to a power greater than or equal to the index. 2, the radicand has no fractions. 3, no denominator contains a radical. 4, exponents in the radicand and index of the radical are simplified. That is, they have greatest common factor 1. We wouldn't want this to create more radicals in the process. And 5, all indicated operations have been performed, such as addition or multiplication. Now let's see if we can make some sense of this. In classroom example 6, let's simplify each radical, starting with the square root of 288. Now, 288 is not a perfect square, but it does have a perfect square factor because 288 is 2 times 144. So one thing that we do to simplify a radical is we take out as many of those factors as we possibly can. We can write this as the square root of 2 times the square root of 144 using our product rule. And the square root of 144 is 12. And I'm going to bring that 12 to the front and write that as 12 times the square root of 2. In part B, we can actually take the cube root of 125 because that is 5. So in our second step, let's write negative 8 times 5 or negative 40. So all we're doing here is we are pulling the factors out of that radical that we possibly can. In part C, we're looking at a cubed root of this radicand. Now let's try to think of some pieces in here that we can take the cube root of. For example, 128 is 64 times 2. 64 being a perfect cube. A to the 6th, that is a squared cubed, isn't it? Okay, so we'll be able to pull out an a squared there. B to the 8th. Let's think of b to the 8th as b to the 6th times b squared. B to the 6th we'll be able to take the cube root of, kind of like we broke up that a to the 6th. We'll watch what happens there. And c to the 10th, let's write that as c to the 9th times c. Now let's take out our perfect cubes. Cube root of 64 is 4. That came out. The cube root of a to the 6th, in other words, the cube root of a squared cubed is a squared. So really just think in terms of division. 3 divides into 6 2 times. The cube root of b to the 6th is b squared. And the cube root of c to the 9th is c to the 3rd. 3 divides into that 9 3 times. Also, c to the 3rd times c to the 3rd times c to the 3rd gives c to the 9th, doesn't it? So what have we taken out and what's left? Well, what's left in here is a cube root of 2 times b squared times c. So let's take as much out of the radical as we possibly can. In example 10, we're going to simplify these radicals. And here we're going to just look at our exponent of the radical and the index and reduce it, if you will. Okay. The 10th root of 2 to the 5th is 2 to the 5/10, isn't it? And it's okay to reduce that fraction in the exponent. 5/10 is 1/2. And 2 to the 1/2, we can also write as square root of 2, can't we? Square root of 2 looks a lot cleaner and simpler than the 10th root of 2 to the 5th, doesn't it? In part B, we've got a to the 3rd to the 1/9 We've got b to the 18th to the 1/9. And you can just think of this as power to a power multiply. 3 times 1/9, that's a 3/9 or a 1/3. And 18 times 1/9 is 2. So we can write this as b squared times the cube root of a. And we're leaving these answers in a radical form, aren't we? Lastly, part C. We've got a 4 squared, and that cube root is a 1/3 power. And our 6th root is a 1/6 power, isn't it? So here we've got a power to a power to a power, and we're going to multiply all of those. That's a 4 to the 2/18, which is 4 to the 1/9, which we can also write as a 9th root of 4. So in each of these, we're looking at our powers and our index, and we're basically reducing those. Let's see, that was 33 and page 34. Operations with radicals. Here we're going to add and subtract some radicals, and what you need to know about that is that we're going to add and subtract like radicals, just like we add and subtract like terms, don't we? Typically, we're used to looking at these polynomial values, and that would be a 5x, where like terms have the same variable and the same exponent. Similar with radicals. Like terms are going to have the same radical and the same thing underneath, the same radicand. So if we look at part A, these radicals are exactly the same, aren't they? So let's combine the coefficients and say 14 minus 11 is 3. So we've got 3 of these square roots of 5pq. We can't pull anything out of that square root, so it is in its simplest form. In part B, as we look at those radicals, they are not alike, but I think we can make them alike, because 75 is 25 times 3. We can take the square root of 25 out. We've got a factor of a, and let's write b to the 3rd as b squared times b. Our second term is minus b times the square root of. Let's write that 12 as 4 times 3, a, b. So I'm just looking at factors such that one's a perfect square that we can take out of here. Square root of 25 is 5. Let's see, the square root of b squared is b. Now, we don't have to use our absolute value bars here because we're assuming that we're dealing with only positive real numbers, so everything's positive anyway. So we've taken out a 5b. Underneath, we've got the square root of 3ab. Our second radical, the square root of 4 is 2. Let's pull that out. We've got a b out, and 3ab stays underneath the radical. Now, these terms are alike because they've got the same radical with radicand, and they have also the variable b. Let's subtract their coefficients. 5 minus 2 is 3. 3b times the square root of 3ab. And lastly, in part C, here we're looking at some 4th roots. So let's start by pulling out as many perfect 4th powers as we possibly can. That's 2 times the 4th root of. Let's write m to the 9th as m to the 8th times m, and p to the 6th as p to the 4th times p squared. Our second term, 3m squared p is outside, and that's a 4th root of mp squared, and nothing's coming out because those powers are too small. They're smaller than the 4, aren't they? Okay, so here we go. Our first term, we've got a 2 times. 4th root of m to the 8th is m squared. Fourth root of p to the fourth is p. Underneath remains mp squared. Minus 3m squared p times the fourth root of mp squared. So now is the question, are these two terms alike? Well, they both have m squared p. They both have a fourth root of mp squared. So the radicals are alike, the radicands are alike, the variables outside are alike. They are alike. Subtract your coefficients. 2 minus 3 is negative 1. So I'm going to write a negative m squared p times the fourth root of mp squared. So there we have performed some operations of addition and subtraction, along with some combining of like terms and simplifying radicals.